Okay, 7.1 in your textbook, 388, page 388. We're exploring interior angles of polygons. Our goal is to investigate the sum of interior angles of polygons. Who can tell me what a polygon is? Before we go, polygon, anybody? Michael?
It's a shape with more than two lines.
More than two
sides.
Sides, okay, yeah, Jeff?
So closed, like closed shape.
Good. Anybody else? Yeah?
It's a 2D shape.
It's a 2D shape, good. Yeah.
A 2D shape that is enclosed and has all straight sides.
Good, very good. Yes, that's the best definition. So a 2D shape that's enclosed that has all straight sides. Okay? Polygon, the actual word poly means many. All right? So if you've ever heard of the word poly, which refers to plastic, a polymer. Plastic, as you guys know, it's a multitude of carbon-hydrogen chains. So that's why they call it a polymer, repeating the same thing. So poly, many, gons, enclosed shape. All right, so an interior angle. It's the angle formed inside each vertex of a polygon. Who knows what a vertex is? Ryan?
It's like where the sides meet.
Good, excellent, perfect. So that's a vertex right there, that's a vertex right there, and that's a vertex. And sometimes you see them labeled as like letters, A, B, C. So you could refer to that as vertex C. Okay, so it's the angle formed inside each vertex of a polygon. So this angle, that would be your interior angles. I think it's pretty clear. You can put interior angles into your own words pretty easily. So the most common polygon that we know of is the triangle. Okay, the number of sides is 3. It forms obviously only one triangle, and the sum of the interior angles is 180. Okay, this we should all know and be very familiar with. The quadrilateral has 4 sides. The number of triangles now is 2, and what that means is if you start at one vertex and you draw a line across between that vertex and the opposing vertex, and then how many triangles do you create after that? Okay, so again, starting from one vertex, I can only go across there. I can't go to this vertex because I'm right on the side of the shape then. And I can't go down here because that's not going to do anything either. Okay, so you're starting at one vertex and you're going to the opposing vertexes. All right, so that's what a quadrilateral is. We know that the sum of the interior angles of a quadrilateral is 180 times 2 now, 2 triangles inside the shape. Pentagon has 5 sides. The number of triangles inside is 3. So our interior angles is 540, and that's 180 then times 3. So again, starting at one vertex, I go to each opposing vertex and then count the triangles inside. Okay, so I form 3 triangles. Hexagon, we have 6 sides. The number of triangles inside is going to be 4 now. And then I'm going to have 180 times 4, which is going to help me out with. It's 720. Is that right?
Yep.
Yeah.
Okay. Heptagon, we have 7 sides to the heptagon. Your number of triangles is going to be 5. So you're joining the opposing vertexes 1, 2, 3, 4. I get 1, 2, 3, 4, 5 triangles. Okay, so I did speak about that a little bit before we turn on the video. It's not, you don't have to have all the angles be equal as long as you draw the shape with the amount of sides and straight lines. You're still going to add up to that, and this is going to be 900?
Yeah.
Octagon, we know has 8 sides. It looks like a stop sign. It's going to have 6 triangles inside, and we're going to be at 1080. Drawing to opposing vertexes, 1, 2, 3, 4, 5, 6, 1, 2, 6. And then finally the last one is an n-gon. And what that means is n can be any number, okay? We tend to use n as the variable for just a number. So n could be 10, it could be 30, it could be 100. It just means a number. So n standing for number. Okay, so in an n-gon, the number of sides actually correlates to what the n value is of that n-gon. So if we go back and check this out, we should see that 5 stands for penta. All right, 6 is hexa, 7 is hepta, 8 is octa, and then the last part is gon. Okay, so 3 is tri, and 4 is quadrilateral. I'm not sure why actually triangle and quadrilateral don't follow the same pattern. I guess just because they're more common shapes and they have their own names. Any questions with this so far? Yeah?
Sir, I was taught that there was 2 more after octagon.
There is. There's a bunch more. Yeah. I'm just not naming them all. So I don't know the name of after an octagon.
It's on nonagon.
Nonagon, and then after nonagon, such as
Decagon.
decagon. Okay. And then after that?
It's
11.
Oh.
11agon.
Would it be onzagon, maybe?
I'm not sure. They do all have names though, but an n-gon is just saying, you know, for when we get to a very high number. So who can tell me what this value would be here then? The number of triangles. Yeah.
N minus 2.
N minus 2, good, because you see that pattern, right? Minus 2 off each one of these. So n minus 2 would go in here. And then who can tell me what the angle here would be? Yeah, Michael.
N minus 2 times 180.
Excellent. N minus 2 times 180. Good. And then the pattern we don't know because we don't know how many n there are. Okay, so the first thing I wanted to do is graph this data. So I'm graphing the number of sides versus the number of triangles. So we do get this linear pattern emerging. So when I have 3 sides, 1, 2, 3, I have one triangle. When I have 4 sides, 2, 5 sides, 3, etc. I get this very, very straight line like this. Okay, so what is the relationship between the number of triangles inside the shape and the number of sides? Josh?
The more sides, the more number of triangles.
Yeah, so we call that, actually we call it a positive correlation. Positive correlation. Okay, and that's because it's moving up, so it's moving in a positive direction, the slope is positive. Would you join the points here? So I've already done that. What have I, was that a mistake or would I leave that? Yeah.
It was a mistake because you can't have like half a side, so it should be a dashed line.
Exactly, very good. So you wouldn't actually join the points, and if you were doing a line of best fit, it would have to be a dashed line. Okay? And that's called what type of data?
Discrete.
Discrete. Equation of the line. Who can tell me the equation of this line? Who can tell me the slope, first of all? What's the slope? Yeah, Andre? 1. Okay, so you're saying when it goes up 1, it moves over 1, because rise over run. I would agree with you. Who can tell me the y-intercept? Yeah?
-2.
-2. No, everything's positive here. Oh, wait, sorry.
Yeah.
I think you're right. It's coming down. How can we find it out definitively? So we're finding out from the graph. How can we find it out algebraically?
Oh, no.
No? Anyone know how to find out algebraically? Selvin?
It's the equation y equals 1 and x plus b, and plug in the points of 1 coordinates. 0, 2.
Excellent. So let's plug in 3, 1. So 3 is my number of sides, so 3 is x. 1 is y. Okay, algebraically. Very important that you guys know how to do that. Not just use the graph. You have to know how to do that as well. Very important from the last chapter. Okay, so we know our equation of the line then now, right? I hope. Michael Sacchetti, what's the equation of this line? I'll help you out. Y equals mx plus b.
Y equals 1x plus -2.
Yeah, plus -2 is just -2. Okay, so there's our equation of the line. Very good. Determine the sum of angles of a 20-gon. All right, so how would we do that? Yes.
You would put x as, no, yeah, x is 20.
N is 20, yep.
Yeah,
So we have our nifty formula here, n that Daniel told us about, n minus 2 times 180. We're going to plug in 20 for n, so you have 20 minus 2 times 180. You have 18 times 180. Okay? That will give you your number of degrees in that 20-gon. Alright? I'm just going to finish up quickly. The sum of the interior angles of an n-gon is n minus 2 times 180. The triangle, as we know, has 3 sides. 3 minus 2, because, n is here, so n is 3. 3 minus 2 is 1 times 180. We know that a triangle has 180 degrees. We know that a square has 360. Our formula is confirmed. Any questions? Okay, that's it. Should be